Hello. We're happy to welcome you to today's webinar about how to expose CICS transactions in 5 simple steps. My name is Marty Bacall, and I'm the product evangelist at OpenLegacy. And I'm joined by Jorge Merlet, a software architect, also from OpenLegacy. Jorge will give a demo a little later on in the webinar. But first, a little housekeeping. You can send in questions at any time by clicking on the questions button on the screen. Also, for best viewing, please maximize the screen by clicking on the diagonal arrows in the bottom right corner of the slide. I also want to mention this will be recorded, so you can look at it later on. It'll be the same link as where you're seeing it right now. But now on to the actual presentation. So what are the goals of mainframe access? Because that's always an important thing to think about. What are your goals? And digital systems need access to business logic and data. Business logic is very critical. That's in the mainframes themselves, and digital people actually need access to that. But also, you want easy and consistent on-demand API creation. When the digital teams need the APIs, they want the ability to create them quickly and easily so they can actually get them and do it right on demand rather than waiting. The other thing you really want to have is some clean digital assets that connect directly to the legacy system. So clean digital assets they can deploy easily, microservices, serverless functions, all those types of things. But another thing people don't always think about until later is speed, both at design time to be able to do things on demand and in a consistent fashion, and also at runtime, because at runtime, the last thing you want is for a mobile app or something to click a button, then have to wait a few seconds before it actually responds with data, just because everything's slow. Mainframes are fast. We need to show that to people. But what are the challenges when exposing business logic and data? Well, first of all, there are a lot of legacy solutions people are kind of tired of. Things like ZOS Connect that requires Library Server to be installed. It also requires CTG, which takes an administrator to install on any mainframe, and generally things like MQ and IIB and ESBs and protocol converters. All these things just get in the way of you doing your work. And you usually have to pick certain versions and make sure the integration part is all on the right version. Everything gets very complex. So those are all very important things to think about. But also, there's another thing, which is there are lots of entry points. A lot of integration tools only support screens or custom applications or databases, and then there are tricky things like vSAM, where you have to actually get offsets inside a COBOL file to make it work. So what are the needs for connecting to CICS? Well, we really want to be able to support any CICS version that's being used without having to upgrade the version numbers and having to match your integration and a lot of other complexity. We also want simple installations. You don't want to have to require an admin to install something on the legacy system to make things work, because then you're waiting, as part of the integration team, you're waiting to get an admin and make sure it's all working. Depending upon the size of your team, do you have admins even available? We also want to minimize things like facades. Facades are applications you build on the legacy system which do the data translation. We don't want to have to add applications to the legacy system. We also want to minimize ESBs, because ESBs just slow down your work overall, and it had to take extra maintenance. You don't want ESBs just to do the translation of the data again or to pass it through queues and wait, because that's just a slowdown, and a lot of times a lot of ESBs, parts of it have to be installed in the mainframe, which also slows you down. But something you want to make sure to maintain is security. You want to maintain your mainframe security, but you also want to add in some digital security. Now people are going to access this data via the web, via mobile apps. You want to have all that security baked in as part of what you're doing. Well, how do you get there? Well, first I'd like to show you a solution, a real simplified architecture. We want to think about having your microservice or function as being only things you're showing external that are actually then directly connected through secure connections through HBS. Into your CICSplex, and then connect to your terminal regions directly, which then connect directly into your application regions. In this case, we're showing you a CICS adapter, but that adapter is really just a simple CICS application. So you don't need administrators in order to install it. You don't need all the extra things, and there's nothing else added there. There's no facades, there's nothing else. So this is the solution we're showing you here. We're going to show you how that all works and what are the steps needed to make that work. So what are the steps? I'm going to talk about these steps in more detail in the next few slides, but first I wanted to show you a brief overview of them. We first parse the legacy metadata, then we go on and we actually automatically generate some code, which is actually the integration logic for connecting that to the digital system. And then we design the API and generate it. And then we have automatic test generation because you need to test this whole thing out and make sure it works correctly. And then you really want to make your simplified deployment and runtime. Make everything easy to do, simplified, and easy to work with at runtime. So when we discuss parsing, there's a lot of different types of things you can parse. I brought that up on an earlier slide, but we want to talk about remote procedure calls to applications. These applications could be existing applications, things like FIS, Temenos. We support those directly, SAP. All those things we support directly, but it also might be just languages, things like COBOL or PL1, these applications you built in these languages. We simplified things like the linkage sections inside of COBOL. We can parse XML code, and generally that means you do the code fetching, and then you do the parsing of that data to make sure it all works. Now the next question is, if you want to go directly to data, you want to go to a database or to a VCM file that you're actually looking at via the COBOL copybook. Those types of things are very important, and you actually then use a metadata fetcher to grab the metadata and then to figure out what you need to get, and then there's a procedure call you make to make that all work. And then we want to think about screens. For screens, typically you're communicating with the screen to make everything work. So how do you make that work? You have a trail file. This is you record the screen actual usage of a user, and then we generate that into code. Now because our code, which we'll see in a couple steps, is all open, it actually makes very reusable scenarios. Because a lot of times people have hundreds of screens that maybe people use in thousands of different ways. You don't want to have to do thousands of different trail files to make it all work, because that would be very time-consuming to have to record every single person and how they use it a little differently. What you want the ability to do is record them and then reuse the certain screens you've worked on in other instances, and you can then code that up. So since we give you the access to that, it's very important to make that all work. The next step is actually SDK generation. What do we mean by SDK? The SDK is the element here that's a project that's part of your system that actually connects from your mainframe to your actual API. It does the data translation, the orchestration, integration of data sources. All of this is automatically generated, but you have access to all the source inside of, for microservice, it's inside of Java. It's inside Java. For serverless functions, it's actually inside of Node.js. And we'll discuss that on a future webinar, why the differences. But we also allow you to make consistent generation via templates, because some people have coding standards inside their companies, and it's very important to actually be able to generate that the way you want. You may also have a different security application that your company specifically works with, and you may want to build that directly into the logic, so we can auto-generate that in there using templates. And speaking about security, all the connections are secure. They're through HTTPS and TSL, the newer versions of SSL. We also support, though, the digital type of security, things like OAuth 2, OLAP, LDAP, all these types of terminology that actually work for the web, directory searches, all different parts that you need. Also, the language Java is a strong type language, which is very similar to COBOL in that way, which means that you don't tend to get some errors you get from some other languages that aren't strong typed. And also, we support data masking. What does data masking mean? Well, we're only taking the elements that show up here. Those are the only things you can connect to and actually see through that API. You don't get access to the whole database just by going through one API. And that's a huge way to actually hide the rest of the data, because it's not needed to work with that specific API. The third step is to define and generate the API. Now, for this, you actually want to make the API map to the SDK. Make the API go to the SDK, and for that you actually want to think about whether you're doing contract first, where you already have an API, or contract last, where we generate the API for you automatically. Because in some cases you already have an API contract, we can take that swagger in and then generate the integration to it. You also want simple methods to analyze the inputs and map them to the outputs. So overall, you want to think a little bit about defining and generating the API. We generate it all for you, but you map that information from the SDK directly to the API. And then that whole thing, both the SDK and the API together, makes a microservice. And you can put multiple SDKs and multiple APIs together depending on how you want to deploy your microservice. So step 4, automate the test generation. When we talk about test generation, this is a huge part of any type of development process that you use. And we talk about unit testing, integration testing, regression testing, and deployment testing. And the most common way to do Java is with JUnits. So that's for unit testing and also for regression testing, because you can actually take the JUnits and we auto-generate those for you, and you can actually do testing on the system and make sure everything works from a unit perspective. But the other thing we have is a JSON-based testing framework, because sometimes your developers aren't, or your testers aren't Java experts. You don't want to have to make them write in JUnit and do some extra work there. And so we actually give you default input and output parameters, which then make it much easier to actually test directly the JUnit parts. And then for the deployment and integration testing, we use Swagger, because with Swagger you can put an input into the API and see what the output comes back out. And that's sort of black box testing, but it's also testing the integration of the system, making sure everything works correctly. So a number of different testing, all auto-generated as part of your system, which makes everything work well. And the 5th step is simplified deployment and runtime. Deploy anywhere with microservices architecture. So one of the main benefits of microservices is the fact that they ease deployment. You put them inside a Docker binding, you put them inside a container, they can be deployed on-premise or in the cloud. They can be deployed pretty much anywhere very easily, and this makes a much more simplified process. Since the only thing we're actually giving you in the end is a microservice, it makes it really easy to deploy. Also, it's a direct connection from that microservice to the legacy system, to the CICS system in this case. And that's a direct connection, speeds access. You get really fast access all the way through to the system as you go. So now I'm going to hand it over to Jorge Molet for a demo of all of this.
Thanks so much, Martin. Can you please tell me if you can see my screen now?
Yes, I can see it.
So as I was saying, I'm going to show you right now the generation of an API from scratch. This is a very visual section, so please help me by enlarging a little bit your image using these arrows on the top right, on the bottom right of your image. So it's going to be 5 steps as Marty mentioned. The first one is the generation of the structure of an SDK. We're going to use a CICS transaction in this case to show you how this runs. The philosophy of OpenLegacy is to allow or empower the developers to basically have all the facilities of the development of the code first philosophy, but also to be able to how to generate code as fast as possible and also under a control mode. And the idea is we created some wizards that they're going to be, the developer is going to be executing during the process of the generation of the API. So first step is running the generation of the SDK. There's many platforms that we can use. It could be, from AS400, several ways to enter into the mainframe, use reuse MQ or store procedures or SOAP that you may already have. There's many ways we can talk. Marty already mentioned most of them. So I'm going to use the CICS connector in this case. As I click next, I only need to put the credentials because, as we mentioned, security is very important here. So we're taking the security. We created a demo environment for these purposes. So I'm using that one, entering to the URI map like this. And so Racket is going to take control of security once I get into the server. Let me finish. This is going to create the SDK. And the generation of the SDK is allowing me to have the structure of all the artifacts that is going to keep the metadata that are going to describe each one of my CICS transactions. So the next step is to generate the metadata model from that CICS transaction. And I'm going to use, in this case, code from a copybook. This is the copybook that I'm going to use. You see, it's a little simple. but this is just for for demo purposes. We are able actually to deal with substructures, complex structures of copybooks, also even redefines or fillers or things like that. So what I'm going to do is just go inside it to the SDK and bring my code inside of my SDK. You can do it both ways. You can also do it straight from the mainframe, but in the interest of time, I'm going to do this because it's faster. So I just right-click on the copybook that I want to generate the model from, and I'm going to right-click. I'm going to put a name to that one and generate the model. Okay. And what this is going to do is I could actually create a JUnit from here. The JUnit could be able to be put it inside of my DevOps strategy. I'm not going to do that right now, but I just wanted to show you that we can do that. And if I click OK, this is going to immediately, in a matter of seconds, do the generation and the identification of everything that's inside of the COM area. And it's going to convert that into understandable information and fields and everything inside of the Java code. So the SDK is already taking control of the transporting, modeling, mapping, communication, security. Everything is all together encapsulated here. And as you can see, the sublevels of the structures are already identified, and I can see that information inside of my SDK. So the only thing I need to do here is just to deploy this as doing maybe install to generate the jar file that is going to be the artifact that is going to be consumed by the API. So that's step number 2. Step number 3 is going to be generation of the structure of the API. To do that, I just need to basically use the OpenLegacy menu and put a name to my API. And from here, I can start thinking on the deployment methods. And one of the things that we can do is also play with caching. We have caching at the SDK level. We also have caching at the API level. We can do the contract first project, as Mario mentioned already. But very important thing is that we can start, defining the way you want to deploy. Why? Because you can deploy as a microservice and define which flavor of microservice you want to use. But you can also use templating. Templating is a very powerful tool that we can use at the SDK and at the API level. And it's going to help you to customize or standardize whatever you want to do into your code, like formats or security or nomenclature or naming conventions or anything you want to do. But most importantly, perhaps, is the deployment method. So you can pick and choose that you want to, let's say, deploy to a queue message manager like a Kafka or a specific API gateway. So you can define a custom template, and then every time you're going to create your APIs, you can pick and choose that template, and that's the way you're going to generate your APIs that same way every time, and they're going to be an artifact ready to be consumed by that specific deployment method that you want. Okay? So I'm going to click next, and I'm going to choose the SDK that I just created for you, because what I'm doing here is basically defining what is my dependency. In this case, I'm using one single SDK. It could be used to more than one SDK, and this is where I could do actually orchestration and choreography of the information that I'm getting from my backend. I could be using more than one SDK, bringing information from more than one asset or different sources of data. So as I click finish, this is going to basically create the structure of the entire API. And from the definition of the structure of the API, the only thing I need to do is to define the contract. Usually defining contracts takes several hours, if not days. But since we already make everything understandable from the SDK level, it's going to be very easy to create an API here, an API contract. So I just need to right-click on the API and say generate the API from the SDK that I have, put a name to my API. I could also play here with a generate a unit here as well, and or parallel execution or create pools. That's kind of powers that you have when you're using Java. And I just need to define what are the inputs that I want to have. I can actually create labels at the SDK level. So whenever I see these, it's going to be easier to understand for the developer. Another important functionality is that I could bring back entire structures of data. So that if I bring the COM area completely, the next time somebody changes the code inside of the mainframe, I'm going to keep bringing the COM area even if it's bringing more information. Okay, as I click OK, this is going to generate my my contract. And we have these editors for everybody to see and be able to understand what's inside of the API. You can see that you have access to the code of the interface, the implementation, and the controller as well. In this case, I'm just going to run the API and execute it for you. I've already created the contract. I'm going to run the API and execute it for you on a server specification mode for you to see it executing. This is the fastest way to basically test, as Mari was mentioning. So just go right-click on the API and run the application. And this is going to run in a few minutes and take control of my port 8080. And there I'm going to be able to show you the API that it's running. Just for you to see, I opened a session on a kick session because I'm making sure that we're hitting the finning queue to code that we have inside of the mainframe. So every time I hit here, there's going to be a counting increasing on the number of executions of that program. So for you to make sure that we're executing this code. So I'm going to go right now to the browser. I'm going to open my port 8080 in a Swagger. As mentioned already, we have by default OAuth2 security that can be changed and templatized as well. Change meaning take it off or add new ones, kinds of security. I just need to post my API and try it out. And I'm going to put a number here of the credit card and execute it. And you can see that I'm hitting the mainframe already and bringing information on real time. The first one is the cold call, which is a little, let's call that slower, like about 300 milliseconds. And the execution increases. And also, if I put another number here, I'm bringing different data from the mainframe. And you can see that I'm reading the mainframe back again, increasing the number of executions that I'm having here. So that's the way we create a full API all the way to the deployment and test it for you in less than 10 minutes. Okay. So with that, I'm going back to you, Mari, please.
Thank you very much. So now we're on to some questions, and I see some great questions have come in. One slide seems to show an OL component on the mainframe. That's OpenLegacy component in the mainframe. Can you describe that further? So I guess I'll answer part of that first, and then I'll let Jorge also chime in. So that is really just a simple CICS application that does the TCP/IP connectivity to the digital side of the house, and also does then the URI mapping directly down into the rest of the system, make sure everything goes well there. We actually have a new data sheet that's going to come out that's going to describe it in a lot more detail. That's actually just about to come out in the next week or so. So do you want to describe that any further, Jorge?
Yes, you're talking about the component that we put in the mainframe?
Yeah.
Yeah, we're avoiding to do that in almost every case. But whenever you want to get the best performance, we're trying to go to the lowest possible level of the protocol. And in this case, if you're using CICS transactions, which are going to be the fastest in response time, hitting less than 200 milliseconds constantly, we may going to have to install code inside of your CICS area. It's just one program that you're going to be able to see what's going on, and the code you're going to be able to see it as well. And we need to reserve a port. That port is going to be using HTTP connection. So that's the only two changes that we need to do in the mainframe if you want to do it to a CICS transaction. All the other ways to enter into the mainframe, we're not installing anything inside of your computer. Okay.
So another question that came in is, can you talk about the runtime? Sure, we're happy to talk about the runtime. The runtime is a synchronous call directly to the actual system, assuming you're doing a function call or a database call. It's all very direct. Some people say, well, can I do asynchronous then? Yes, we can easily then apply on the other end, on the digital side, Kafka. or MQ or RabbitMQ, those types of queuing mechanisms on the other end. But we wanted to make sure the connection itself and the runtime was very simplified to just a microservice that connects directly to that CICS connector and then just gets the data right from there and brings it out. And then from there, you can do extra queuing and other work if your system calls for it, but you don't have to. Let's see. Let's see. IBM claims that ZOS Connect is the best system. Can you explain some differences there? Well, we actually have a really good paper that describes this on our website called The Hidden Cost of ZOS Connect. But to cover some of the basics, they require you to install a connector. They require you to have Liberty servers, specific versions of the actual OS and of other things, which is a lot of work for administrators to make work. Plus, they don't really produce actual microservices. They're just trying to expose the API directly on the mainframe and make it do a lot of things that are very internal to the mainframe itself. So they aren't very DevOps friendly in that sense because all the changes you have to do on both sides and work with both teams. Whereas we expose everything as direct microservices, and we don't have to add anything to the mainframe side, and we don't have to make you use things like MQ on the mainframe to make things work well. So there are a lot of big differences, but I do suggest you go to the paper called The Hidden Cost of ZOS Connect on our website, which describes that further. Jorge, do you have anything to add to that?
Yeah, I could actually also comment that basically you don't need to do any changes on the configuration of the mainframe. No changes on the kick specs or new LFARs or anything like that. We're just using one single code inside of your AOR, and that's basically the only thing you need to configure there. And it's not invasive. You don't need further changes into anything to do tests and create new products or things like that. So it's very simple.
And I guess we'll take one more question since we're already at 10:30 here. But one question which is sort of just answered, which is which solution are you using to reach CICS? And the answer to that question is our own solution. It's our own adapter generally. I mean, you could use something like CTG if you chose to, but in general, it's our CICS adapter that we wrote, which is just a simple CICS application. And that's what we use to connect to it. And from there, we just have the microservice that calls directly into that. There's nothing else added. There isn't anything else from there. So I guess there were a lot of other great questions. Yep. Do you want to add one more?
Yeah, we're also reducing the number of MIPS because we are not creating overhead in the mainframe. We're bringing, all the transportation and mapping and modeling, all that to the Java part instead of keeping that inside of the mainframe.
Yeah, and there's one more that I really wanted to hit on, which is, do you need any custom coding to connect legacy asset? No, you don't need to do any custom coding. You could choose to, on the microservice side, to do other things to advance beyond, and we've templates to automate even that part of the process. But you don't have to do any custom coding. Everything that Jorge did just now was live. He didn't have to do any coding to make that work. So that kind of just shows you how easy it is to make it work. Anyways, thank you very much, and we'll follow on from there. And thank you, Jorge.